Okay, dear students, let us study absolute errors, relative errors, and percentage errors. Absolute, relative, and the third one, percentage errors. Okay, let us see first about the absolute error. So the absolute error of a number is a numerical difference between the true value of the quantity and its approximate value. Actually, it is a difference between. So numerical difference between true value of the quantity and the approximate. It's approximate. The difference between true value and the approximate value. So this is called as the absolute error. If x is the true value of the quantity, and your x bar its approximate value, then that difference, let me denote it by EA. There is the absolute error as the difference between the true value and its approximate. This is denoted by EA is equal to modulus of x minus x bar. So this is called as the absolute error. So the relative error, let me see what is the relative error. Let's see the relative error. So the relative error is denoted by ER, and it is defined as modulus of x minus x bar divided by x. This is called as the relative error, and I can also write it as EA divided by magnitude of x. This is called as relative error. See, if the percentage, the third thing is that percentage error. So you can guess the formula. So that is denoted by EP. EP is equal to 100 into ER. If we multiply 100 to the relative, we will get the percentage error. So that is 100 into what is your ER, relative error, that is x minus x bar divided by x. This is percentage error. So if you get the question to calculate the relative error, absolute error, percentage error, you need to use you should remember these formulas. See, if I take any numbers, so let me take, for example, let me consider, let us make a small observation here. Let us take the number 1.1346. So the rounding of to 3 digits, rounding off to 3 decimal places. So what would be your answer? That is 1.135, right? This is your approximate. See the rounding of error. What is the rounding of error? It's the difference between the actual value and the rounded value. So let me see the rounding of error. Take the difference between actual value and the approximated value, rounded value, that is 1.1346 1.135. Take the absolute value, you will get that is 0.00004. Right, this if you take the true value and if you take the true value and again the difference of that rounded off number, you will get the difference as 0.004. If you take any number and you round off it to a 3 decimal places, it won't go beyond 0.0005. You can check taking any two other numbers this answer is right or not. If you take any two values, if you take any number and round off it to 3 decimal places, you won't get the difference greater than 0.0005. So I can write this as 10 point minus 3 divided by 2. Please note this, think of it, how it came. Think of it. So if you take the number and if you round it off it to 4 digits, you get 10 to the power minus difference as difference always the maximum difference is 10 to the power 4 minus 10 to the power minus 4 divided by 2. In the case of rounding off to 3 decimal places, rounding off to 3 decimals, you get the difference, maximum difference is 0.005. You get the below of that value, you get any difference, but the maximum difference, it cannot go beyond the 0.005. In 4 digits, it is 10 to the power minus 4 divided 4. And similarly, the for the nth value, this is not for the nth value, it is less than or equal to 10 to the power minus 4 divided by 4 for nth digit. Whenever a number is rounded to n decimal, the maximum rounding of error is always 10 to the power minus n by 2. Please make a note of this. So for 3 digits, it's 10 to the power minus 3 by 2. For 4 digits, 4 decimal places. 4 decimal places is 10 to the power minus 4 divided by 2. And for the nth digits, this is for the n decimal places. N decimal places. So you have 10 to the power less than or equal. The maximum difference is 10 to the power minus n by 2. So let us see some problems related to absolute, relative and percentage errors. So here is your first question. Round off the number eight six 5250 to 4 significant figures and compute EA, ER, EP. EA stands for absolute error, ER stands for relative error, and EP stands for percentage error. So let's see the solution. So your number is take the given number as x is equal to 865250. So you have 1 2 3 4 5 6 digits, but you have to round off to 4 significant figures. So number rounded off to your now number rounded off to 4 significant figures, that is equal to x dash, that is, see how many number, 1 2 3, I can write first 3 digits without fear, 865. Now look into this 2. So you have 5. Sometimes when you have a 5, you have to add, but in the textbook it is taken as 2 only. When you have a 5, there is a ambiguity, you have to take or increase your this digit, or you have to retain. In the textbook it is taken as it is, so I'll take it as it is. You can take no problem, you can increase the number. So let me take it as a no, will increase. In the textbook it is given that 865200, because they are treating they have kept 2 as it is, but I'll take this since you have 5 here, so I can write it as 8655300. Now compute your EA, absolute error. What is your absolute error? EA formula is EA is equal to magnitude of x minus x bar. So your magnitude of number is that 865250, actually the given number, and the x bar is the rounded off number, that is 865300. So what is the actual difference? The difference, not the absolute difference, that is 50. You have taken 50 absolute here, so you won't get negative value, so you have positive value. For error we are taking here, for absolute error we are taking the here modulus. So now what is ER? Your formula ER is, so for ER you have magnitude of x minus x bar divided by x. So it's x minus x bar is already calculated, that is 50 divided by, what is your x? X is 865250. If you use calc to get the answer for this, you would get 6.71 into 10 to the power minus 5. This is your relative error. Now let us see the percentage error. EP is equal to, so that is ER into 100. So what is your ER? That is 6.7 into 10 to the power minus 5 into 100. So you get 6.7 into 10 to the power minus 3. So here the 10 to 100 can be written as 10 to the power 2, and these two powers adds up and we will get 10 to the power minus 2. Let's see the second question. Round off the number .37 46235 to 4 significant figures and compute EA, ER, EP. So similar to above. So you will get 3 marks question on this topic for your semester exam. So your actual number is x is equal to 30, sorry, not x bar, it is x x is 37.46235. So your x bar, that is the number which is this is the same number which is rounded off to 4 digits. See, I can write first 3 digits as 37.4. Look at this. So after this, after 6 you have 2 which is less than 5. You can, so no need to change anything. So let me write 4 6. So 0 0. After the 6 I'll write 0 0. Now you take the difference of these two numbers for absolute error. So EA is equal to magnitude of x minus x bar, that is your x is 37.4625 minus your x bar x dash is 37.4600. So what is your answer? Your answer is 0.00235. This is your answer of absolute error. Now let us calculate ER, that is a relative error. So ER, the formula is mod x minus x bar divided by x. So you have x minus x bar, it's already calculated, 0.00235 divided by your x bar is that, so x is not x bar, x dash, that is x is 37.46235. so you'll get 6.27 into 10 to the power minus 5. This is your answer. 6 point. Now you have to calculate percentage error, that is EP, that is equal to ER into 100. What is your ER value? That is 6.27 into 10 to the power minus 5 into 100. You will get 6.27 into 10 to the power minus 3. This is your answer. The problems are very, very simple. Let us see the third problem. Find the absolute error if the number is x is equal to 0.00545828 is, the first question is that truncated to 3 decimal digits and rounded off to 3 decimal digits. B question, rounded off to 3 decimal digits. So the first condition is that truncated means you have to cut the number. In this case you have to truncate it to 3 decimal digits. We have to we should not write after the 3 decimal digits. Your number is x is equal to, given that x is equal to 0.005452828. So in the first place, what is your x dash? So you have to truncate it, not round it off. Don't confuse with the truncated and rounding off. So you have to remove the after 3. See, 1, 2, 3 or decimal 3 decimal digits. After this you have to remove. So that is, your number is 0.00545. So you have to calculate the absolute error. So EA is equal to mod x minus x by x minus x bar, that is equal to, the answer is that 8.28 10 to the power minus. I have calculated this already. So please calculate it, you'll get the answer. Check, verify with my answer. Now if I the B question, round off to 3 decimal digits. So what is your x dash is, see, 0.0054. so third digit is here, this is 5. See, look into the next digit, that is 8, which is greater than 5. So I can write this as 6. So 0.0056 is the number which is rounded off to 3 decimal digits. So your absolute error EA is equal to mod x minus x bar, which is equal to, not x bar, it's x dash. So you get 1.72 into 10 to the power minus 6. And substitute and get the answer. I have already calculated, that's why I am writing the answer directly. Plus please check with your answers. We'll move to the next question. Your next question is fourth one. If 0.333 is approximate value of one by 3, find absolute and relative error. So your actual value is x, that is the actual value x. You have x is equal to 1 by 3. See, it is given that 0.33 is the absolute approximate value of this is 1 by 3. So actual value is x. So I can write, so this is not x bar, this is actual value or x. So this is, I can write this as 0.3333. So one more digit than the approximated value. So your x bar is, that is 0.333. So now you calculate EA, that is x minus x bar, sorry, x not x bar, it's x dash. You get 0.3 into 10 to the power minus 3. So similarly you calculate ER, the formula is mod x minus x dash divided by x. So that is equal to, you get 0.90 into 10 to the power minus 3. These are your answers. Please verify your answer. We'll move to the next question. Find the relative error in taking pi is equal to 3.141593 as 22 by 7. So let's see the solution. Your actual value is this. Actually it is the approximated value. This is your approximated value. So your actual value x is equal to 22 by 7, and your approximated x dash is equal to 3.141593. Let us substitute to calculate the relative error. Let us calculate first absolute error. So that is EA is equal to mod x minus x dash. You get for substitute x is equal to 22 by 7 and x dash as 3.141593. You calculate using calci, you get 0.00012645, and actually we have to calculate the relative error, that is ER. So your ER is formula is mod x minus x dash divided by x. So x minus x dash is already calculated, you just divided by your actual number, that is 22 by 7. You get 4.0250 into 10 to the power minus 4. You get this answer. Please verify this answer. Let's check this answer. Please have a calculation in your book. Step by step calculation. You have to show the substitution and calculation. So the next question. Question is the height of an observation tower was estimated to be 47 meter, whereas its actual height is 45 meter. So calculate the percentage relative error in the measurement. So let's see the solution. So it is given that the height of an observation tower was estimated to be the 47 meter, whereas its actual height is 45 meter. So you have to calculate the percentage or percentage relative error. See, your actual height is 45 centimeters. So your actual value, that is x is equal to 45. So the approximated value, let me take it as x dash is 47. So you have to calculate the percentage relative error, that is your EP. EP is equal to magnitude of x minus x bar divided by x into 100. So that is equal to, if you substitute everything, and you will get 4.4 plus. Please have a substitution in your notes. Okay. So next we'll see the next question. Your next question is, suppose that you have a task of measuring the length of a bridge rivet and come up with (9,099) and 9 centimeter respectively. If values are if values are 10,000 and 10 centimeter respectively, compute the percentage relative error in each case. Okay, this is your question. You have to take the you have a task of measuring lengths of a bridge and the rivers. You have come up with the measurements as 9,999 centimeter, which is the length of the bridge, and 9 centimeter is the length of the rivet, and the actual values are 10,000 and 10 centimeter. So now you calculate the percentage. So let us see the solution. So for bridge, your actual value is 10,000, but actually you come up with the 9,999, that is x dash. So your percentage, relative error EP is equal to mod x minus x dash divided by x, that is into 100, that comes out to be 0.01. Have a substitution and get the answer. For rivet, you have your actual value is 10 centimeter, but x dash is 9 centimeter. So if you substitute, EP is equal to magnitude of 10 minus 9 divided by 10 into 100, you get is equal to 10. Your percentage relative error is 10. So this is all about the problems related to the absolute, relative and percentage error.